you. Here we go. All right. So just as a quick overview of what's happening here, since it came up many times in the introductions, a lot of people are here to just pick out a few things and add it to a course or curriculum. And I understand that. That's usually what I do when I attend teachers' conventions. And this course is designed to make it easy for you to do that. So everything you need is here at samsclass.info. And the course is here. And it's structured. There are some lectures, which I'll do, but then there's a lot of hands-on projects, and they're structured like a capture the flag contest. And the idea is you can just use them the way they are, and you could even assign them to your students right on my page and have them submit flags and get graded right on my page if you want to, or you can just copy it and modify it and turn it into whatever you need for your courses. So this is, that's the whole idea. Is you might not want all of this, but you might find just a few items that are appropriate for your use, and you're free to use them. So let me move into my summary presentation. You see I fit this on the board pretty well. All right, so I'm Sam Bound. I've been in IT for what must be 25 years now, even longer than that, really. 25 years in college teaching, and before that in industry. So I'm on Mastodon. I left Twitter like pretty much the whole information security community shortly after Elon bought it. And everything I hear about it makes me glad I left. Anyway, I also do corporate training. I'm a corporate AI consultant for a company. And so that helps me a lot to work in industry to help put more realism in my courses. And like I heard another instructor say, I've run into AI over and over and over again in my career, literally for 50 years. I kept bumping into various machine learning features, and it was always pretty useless until recently when it suddenly crossed a threshold and became very valuable. And this, I think, helps a lot, is the Gartner hype cycle. Gartner is a business projection company that helps guide people into what investments to make. And they have the famous hype cycle, which I think is extremely helpful, where when something comes out and it's new, everybody doesn't even know what it is. Then as it grows, people say, this is the greatest thing ever. This is going to change everything. We're going to fire all our employees and replace them with machines. It's going to solve every problem. And then things hit the peak. And generative AI, they put up here, it's actually heavily invested in, used everywhere, but people are beginning to notice that there are limitations and problems with it. And pretty soon thereafter, they will turn against it and be disgusted as their original optimism is shattered, and then they will get too angry at it and decide it's worthless. And then after all the nonsense is over, it'll just settle down and become another technology like everything else, like the internet, like spreadsheets, like cars, where it just adds something to us, but it isn't terrible and it isn't fantastic solving all our problems. Like they say, computer vision has pretty much finished the whole cycle, where now you have it in say, Tesla cars and all over the place. And it's pretty much just a standard accepted thing that devices can see. Generative AI is way up here at the peak, where people are just throwing billions of dollars in it. I saw a news article recently where currently to train a major large language model costs $40 million. And people say pretty soon they're going to have ones that cost $100 million. And the companies that do it say, oh, we'll cheerfully make ones that cost $1 billion or $10 billion or $100 billion to train, as if people are going to spend that much. And yet the serious business people are already saying, we've invested a lot of money in this, and it's not actually accomplishing anything of value to us yet. So they're beginning to say, I'm not sure it's worth throwing more money into this. It's not clear it's all that valuable, and so on. So I think this helps you get some perspective on this. So let's talk about types of machine learning. The simplest type to understand is supervised learning, where you have training data with labels. So for example, you might be making an email spam filter, where you have a bunch of email that some human has marked as spam and some email that a human has marked as good. And now you just want to make an automated system to tell good mail from spam. Now, that's one simple case. But more commonly, you have unsupervised learning, where you just have a pile of data. Like you can go on the web and find a whole lot of writing, like Reddit. You have millions of pages of English writing, but it's not labeled in any way. So it's not immediately obvious how you can benefit from that. Well, one thing you can do, though, is you can just sort it into groups. cluster it. These seem to be a group, that seems to be a group. That's one thing you can do with unlabeled data. And you can also do anomaly detection, which is an obvious extension where you make a group and you call that normal, and the ones that are far enough outside it, you call the anomalies. So you might be finding the suspicious credit card transactions or the defective products on an assembly line and so on this way. And a really powerful technique, which is at the heart of all the large language models, is this one. You take the unsupervised data and mask part of it. And now you try to predict the part you've masked. And now you know the right answer. So you've taken unlabeled data and turned it into labeled data. And this turns out to be extremely useful. And in a very influential paper from 2017 at Google, Google published the paper that led to the entire rage of large learning models we're all using now, large language models. They figured out how to do this. And what they did was they would take data and they would mask 15% of the words. So you have a sentence that you got somewhere in your data, artificial intelligence mask take over the world. You mask this word, and since you masked it, you know what the right answer is, and then you train a model to predict this word from the context. What word would be appropriate? And here's the results of BERT, a common model. It has 32% chance of being can, and 18% chance of being will, and so on. So you have learned how to place words that will be appropriate in the context of the words around them. So you can make sentences that sound good. And then in the second step, you take sentences, and half of the time you replace the second sentence with a random sentence. So you train the model to put sentences in an order that makes sense. And that's all. That's all these large language models do. They just know how to make sentences that look appropriate and series of sentences, say paragraphs that look appropriate. And that's what passes for machine intelligence. And someone says, is that the same as vectoring the data? Well, it is no. Vectoring the data is just placing the words or tokens in some kind of logical order. And this is part of it. Yeah, I think this is part of the process whereby, yes. Let me revise my answer. This is how you train it so that the words actually get placed in, represented by vectors that have meaningful locations. And we're going to do this in the hands-on project. It's the latest one I've added to this course, and I was very happy to get it working. So we will see how it does learn here to place things in a meaningful order. And that is the sense in which large language models have meaning to the words. They know what words are similar in meaning, and they know what words are different in meaning, and the difference is even meaningful. And we'll see this in the project. If you take the encoded vector for king and the encoded vector for man and the encoded vector for woman and make a difference vector, and then you start from king and move that distance, you get close to queen. So that's the sense from training with this sort of unlabeled data and using this masking technique, you can get things correctly placed in a 768 dimensional space, which is the current model for a language from BERT. And we'll do that all in the hands-on projects. So then the issue comes, like any other technology, once you've got it working more or less, now how are you going to secure it? And so you'd like to quantify the risks and you'd like to understand what controls are available. And the government has been there to help us. The National Institute of Standards has made a model of artificial intelligence risk management. This is at a very high level government level. So they're thinking about things like democracy being harmed and discrimination against groups and so on. And then, of course, there's harm to an organization, their business, security breaches, or their reputation if their AI runs badly. And this certainly happened with, I think it was Lenovo, made a facial recognition laptop and it only worked on white people. It couldn't recognize black faces. And that's the sort of thing that's bad for your reputation. If your machine learning model is functioning very badly, then, of course, people get mad at your company. And then, of course, there's harm to the supply chain and the global financial system and the planet, and so on. These are all considerations. Now, one useful diagram from here, which I think helps it, is you'll see all these techniques. Now, we're going to do hands-on projects with all these machine learning techniques. But there's the general pattern here. The more powerful they are, the more difficult they are to understand and control. And that's interpretability goes down as predictive power goes up. Linear regression is where you just have some points and you fit a straight line through it or some other curve like a polynomial. And that's easy to understand and easy to control, but not very powerful. Decision trees are just a series of if-then statements. So again, relatively easy to understand. K-nearest neighbors is a wonderful way to classify data. It's been around for a long time. It's extremely effective at finding groups in the data. And random forests just combine a large number of these simpler things like decision trees just so the random variation will average out the errors. Support vector machines draw usually a line through the data in a high-dimensional space. And the most powerful models of all, like the current large language models, are deep neural networks that are a sort of cartoonish simplification of the human brain with layers of processing. And because they have layers of processing, you cannot say why it does anything. So if it predicts a certain word, you can't isolate what part of the model caused that or how you would adjust it to prevent that. So if you have a security goal, like say, make sure your large language model does not say something racist or write malware or tell people how to build a bomb, it's not easy to enforce that security rule because you cannot really figure out what part of the network does that and what change would be necessary to prevent that, because it's very difficult to interpret how the model works. So we've seen the hype cycle already. Then the UK has also put up principles for the security of machine learning. And this, I think, is actually more helpful than the NIST standard for practical companies to use. It considers all the steps. You start with your general goals of what you're trying to accomplish and your risks and policies. Then you decide the requirements, gather your data, choose a model, and then you verify and validate the way your model works. And then you have to monitor it, just like anything else. You're going to have to continuously monitor your model and keep logs of its errors so you know how well it's behaving. And then it's going to continue to learn and continuously improve like any other part of a modern system. And at the end, you're going to have end of life, some way to dispose of all the data and consider the lessons you've learned. And this, I think, is a helpful guide to help people design secure systems. Also, OWASP, the Web Application Security Project, has made 2 lists of the top 10 risks for AI. The first one is for machine learning risks, and there's quite a few things we'll talk here. Might as well go through them. Input manipulation is evasion. This is extremely common. And at DEF CON, they used to hand out T-shirts with shiny bits on them or hats with shiny bits on them and say, if you wear this thing, it makes bright spots. And now machine learning facial recognition systems can no longer recognize your face. And we will do this in the hands-on projects. You will see how adding just a little bit of noise or snow to images causes AI systems to fail to recognize them. So that's evasion. Then data poisoning. If you can manipulate training data, then you can cause the model to do something bad. This happened to Microsoft. Microsoft made a chatbot on Twitter, and it learned from what people said to it. So within a day, it learned to say terrible racist things, and they had to take it down. My first thought when I heard about this one is normally, how could you possibly manipulate the training data? But now more than half of the data on the internet is in fact AI generated. So you could just put data of some malicious type on the web and people will just hoover it up and train from it. Then there's model inversion, which is when someone steals your model, which you spent a lot of money training, by just carefully putting in inputs and measuring the outputs to deduce the parameters. Then another similar one, membership inference and model theft. These are all very similar ones. And then there's the supply chain attacks. All these AI models use libraries like all modern code. And as we've learned since SolarWinds, a lot of these libraries can be subject to supply chain attacks. And that is a big problem that is largely unsolved. Then there's transfer learning, where you fine tune a model as you train it. You train a model on one task and fine tune it for another task, which can have unexpected results. As we're going to see, I don't think that is as important as it first appeared because this fine-tuning a model with more training is not the common procedure anymore. Instead, it's retrieval augmented generation, which is what we're going to do in the hands-on project, which is a way to add more data to a model without going through another cycle of training. And then there's model skewing, where your data is somehow biased, and therefore your model learns a biased result. Output integrity refers to the situation where your output is dangerous. For example, your model might produce output that contains, say, code script tags, which execute on the web page. So whatever output you make, you should really check it to see if there's something harmful about the output before using it, and so on. And neural net reprogramming is changing model parameters. This is all pretty technical, and a lot of those are not very practical. I think this one is much more practical, the OWASP Top 10 for large language learning models, which are the ones that are getting most of the attention now. Prompt injection is the one we're going to do in the first project. This is actually a very serious issue, and it's very closely related to the standard security problems of code injection and SQL injection. It turns out that the questions you ask large learning models are processed the same way as the instructions from the administrator that set the security policy. There is no separation there. What you would like is to have some way to have high privilege data from the administrator that says, here are the rules. You must not tell people how to build a bomb or make malware or something. And here's the questions from the user. And the questions from the user are lower priority than the rules from the administrator. And the current models do not have any way to do that. So you can ask a question which fools the model into breaking its security policy. And that is extremely easy to do and very difficult to prevent. So we'll play with that. Then insecure output handling is where you use the output without carefully examining it. So it might include scripts that affect the user or otherwise have unexpected results. And if you can modify the training data, the model can learn bad habits. And of course, you can just flood it with requests that cost too much CPU and cause denial of service, like any other web property. And the supply chain vulnerabilities we talked about, your model depends on libraries that may be insecure or harmful. And this is one that gets a lot of attention, and I'm very glad to understand it more thoroughly now. If you use the online free services like ChatGPT and Google Gemini and so on, they warn you if you use the free service, they are going to train the model on your question. And people over the last few years have done things like take a company spreadsheet full of proprietary data and feed it into ChatGPT and say, summarize this for my report to the board. And it's learning on that data, and the model might repeat that data back to another customer. So it's going to disclose the information you put in, and that's why all of the large corporations have forbidden their employees from using these free public models, because anything you feed into there is at risk of being disclosed. And this shouldn't happen. If it does happen, it means the models are being overtrained, which is apparently true because authors have tried to find out if their book was used to train these large models by putting in, say, a page from their book and seeing if it can reproduce many following pages, and it totally does. So it does leak out the information it was trained on verbatim, which indicates that they're not perfectly learning correctly. What you wanted them to learn was the trend of, say, English. So they learned the general structure of English, not to memorize whole pages and books of information and just repeat them back verbatim. And to some extent, they are doing that memorized thing. And then, of course, if you have plugins adding more code, they may be insecure. And this one, even though it's number 8, I think this may be the actual largest real security flaw in practice. Where you trust the large language models to do something that they really aren't smart enough to do. This happened a few years ago in the military. The U.S. military tried to deploy robot soldiers, and in all cases, at least of a few years ago, they would turn around and shoot the wrong people because they really weren't accurate enough to tell who they could be shooting. And you could argue that Teslas have this flaw. An AI or a machine learning model is looking at the picture, trying to decide where to drive, and frequently it makes a mistake. So you've given the machine a power that is not really smart enough to have. And the very similar one, over-reliance, where people trust the output and use it. And there's a lot of stories about lawyers that go to court with a brief that was written by a large language model and is full of lies and so on. People ask these things questions and believe the answer because they don't understand how unreliable they are. And then, of course, we talked about model theft. So I think the main business version of these large language models that people are interested in is Microsoft Copilot. Microsoft is by far the leader in this field at making a real practical commercial product that you can use now. Everybody else has what I'd call an early prototype or beta version, and this is Microsoft 365 Copilot. So Copilot can examine all your cloud data and write answers for you. So it sees your emails, your spreadsheets, and everything else you've got. And you can then ask it to write a summary of something based on all that, which is quite useful. And it does it with retrieval augmented generation, which we're going to program in the hands-on part of the class. So it goes to all your stored data, and it uses something called Microsoft Graph to encode and pre-process the relevant data. You ask it a question, it does a search through all the data it can find, and then it adds that data to a query, which it sends to a cloud-based large language model. And Microsoft promises that if you're using the paid version of this, they will not train on your data. And now you can get a well-formatted English response based on all that data to help you in your business. And a lot of people want this. The problem is it's not quite clear how the security works. And one huge issue, which is not really Microsoft's problem, but is a problem with all cloud security, is that it can leak out sensitive data. You might have emails that say, here's the changes we're going to make next month, and this will involve laying off these people. Don't tell everybody about this, only the managers. And if that data is not labeled with some kind of security label, then it might be included in a thing you write that is disseminated more widely. And the fundamental problem here is that the permissions of cloud data are not correctly set. So here's an infographic from a company saying that there are 40,000 permissions in multi-cloud environments, and only 1% of permissions are actually used. Over 50% of the identities are super administrators with full access to everything. And as you can imagine, in this environment, it is quite likely that your answer will include data that really was not intended to be widely distributed, and it's just up to the human user to notice that, which is very difficult when the model is gathering data from many sources. So this is a fundamental problem with the cloud. The cloud is not correctly labeled with sensitivity labels at most companies, so there is no way to control the sensitivity of the output, and that may lead to trouble. So here's some more fun facts about this. All right, there is something called Microsoft Purview, where you can put a sensitivity label on data, and then it will apply that to the output, but it only works if you have already labeled your data, and unfortunately, every company seems to have dumped a ton of data into the cloud without labeling it, and they don't want to go to all the work of labeling it, so that's a problem. Anyway, here's some tools I found useful for instructors. Perplexity is pretty famous. It's basically a retrieval augmented generation, so it's a large language model that can answer questions, including information from the current internet, nicely. Consensus is designed specifically for research. Instead of just reading random data on the web that might be wrong, it reads peer-reviewed scientific journals and gives you links to those scientific journals, so it's more high quality responses. Anything LLM we're going to use in the hands-on project. This is an easy way to make a large learning model running locally on your own system and customize it with additional data you add for a specific purpose, which is what I think most of the companies I deal with really want. They don't want to trust those cloud models at all. They want to run it locally, and they also want to add their proprietary data to it. Ollama is another way to run large language models locally, and we'll do this in the hands-on projects. And we got a lot of these to do. So the URL for these is a little different for this class. I didn't update that. But let's get into the hands-on projects. So let me show you how this works, and we'll get started on the first batch of these. I think I'll make a separate video of that, so it's easier for people to find the good stuff later.